Hi everybody and welcome to Geotek's Development Laboratory again. I'm very excited to be joined by Todd Houlahan, Director of International Mining at Evidence Scientific, formerly Olympus, and also Marcus Lake from Phoenix Mining Technologies, who is our sales distributor and representative for the mining industry and also a distributor for the Olympus Vanta as part of Evidence Scientific as well. It's great to have you both here inside Geotek's Development Laboratory to talk a little bit about the history of what we see in portable XRF, its applications and what we're doing so far. So, Todd, Marcus, in front of you is probably a couple of analyzers that you haven't seen for a while, including this one here of the Innovex Alpha, which is one of the first portable XRFs we put onto the system when we first started collaborating, which is nearly 15 years plus ago. So, with these three instruments in front of us, could you give us a little bit of an idea of the history and evolution of the technology that you can see and how that's sort of taken advantage of in the portable XRF market?
Great to be here, James. Thanks for having us. Well, I saw that the manufacturing date on that old Alpha was 2008, which is when I first started collaborating with you guys, but you were collaborating with our forebear Innovex before that. And then the Delta was around 2010, I think, and the Vanta's around 2016. It's hilarious looking at them, it's brilliant. But, I mean, the main differences are around operating system, it's around detector technology, it's around detector windows, it's around processing power, and it's around the electronics of counting photons that are coming out of the sample when we fluoresce a sample. So early stage alphas were silicon pin, I don't want to get too technical, silicon pin detectors which could not do light elements, aluminium, magnesium, silicon. Silicon drift detectors then came in on the Delta, which then allowed us to do that aluminium, magnesium, silica, but also lower our detection limits with this greater detector technology, but also the computing power. We really invested a lot in processors. You talked about digital pulse processors earlier today when we were chatting. But then with the Vanta, we really tried to perfect that ability to count more of the X-rays that we're receiving on the detector, less dead time, and better rereproducibility and stability inter-instrument and intra-instrument. So I suppose that's the and speed. So what would take you maybe 20 on a seconds on a Delta probably takes about 10, and on the Alpha would be minutes. Yeah,
it just goes
to
show
looking
that
at my life here. But it's great.
It's great. It's amazing to think the speed differences in the technology. I mean, that's only 10 years, and the differences that's made in that detector technology. I mean, that must have made such a big difference to what we've been doing in the sales front.
It did, yeah. I mean, when I started with Todd in 08 to 19 directly with Olympus and Todd, I mean, when we first started, there was a machine in between which we're missing in the Amiga. I mean, no one was using it, and now they're ubiquitous in the mining industry. It's the first thing they go and buy when they head out bush or to do their work, and the mining companies are using it. Labs are even using it now.
Which is incredible.
In 08, we used to go around the labs, and they used to say these things don't work, and now all the labs have got programs of portable XRF.
And you're selling to a lot of labs, but people don't know how long we've been collaborating.
No, right.
You know, pre-2008, 15 years you've been integrating all these different systems on the MSCLs and now the box scans.
Well, that's absolutely right, Todd, because I mean, I remember when James Parker, who used to be your UK rep from Olympus, came in with the Vanta, and he said, "Oh, James, you should check this new Vanta out." And we'd just come off the back of a project in France where we were measuring some dolomites. We took our own helium-flushed XRF head, and I thought, okay, James, well, we'll test out how good magnesium really is. And it blew me away. It genuinely blew me away. So I completely believe everything you say about the ability to count statistics, get a better performance in the light energy elements. We could absolutely see this was dolomite. You see the calcium, you see the magnesium, and it was just staggering. And immediately all those fire pins start going in your head. You're thinking, well, hang on a minute, what can we do with this now? This can now act as a mainstay of what we're doing in the multi-sensor core loggers. And that really explains a little bit about our own progress with portable XRF and mounting it onto systems like you can see behind you. When we first started, we were doing this pretty much exclusively in the oceanographic market, marine geoscience, doing a bit of paleoclimate work. We sold 2 or 3 of them pretty much a year to some specialist outfits. And that started to grow. But when the Vanna came along, things just took a different level, because all of a sudden the speed performance of what we see, the counting statistics, and that really drove the market. So since the Vanna's come through, the industrial market has really taken off for us. With a lot more in oil and gas labs, mining industry and the mineral exploration industry are really kicking off and through. And I suppose we're getting close to 50 Vantas that we've now, or 50 XRFs that we've now bought over the years. So, mineral exploration and mining is a market sector that's really rapidly growing for Geotek, but of course it's probably you guys' bread and butter where you started and grew the business up. So how the technology has changed for us, it's made it much more accessible, more people using it. So what about for you guys? The same must be true.
Every different phase of the exploration process has application for the instrument. Then when you get into the mine, we've solved for every different application in the mine as well. Started with basic copper, lead, zinc, arsenic, base metals in soils, and then people started going, oh, wait a sec, we could use some gold pathfinder elements here. Yeah. Then some of the more lighter elements, sulfur for acid mine drainage, for environmental applications, and then as the Delta and the Vanta light element capability came in, a lot of people would start to do more sample preparation to get a more homogeneous sample, put it in a cup or make a puck to get really good quality light element data that then enables them to look at stratigraphy, ratios of immobile elements, to look at lithology and those sort of things. And core, I didn't mention spot testing core, but then it went round to stratigraphy and a lot of sample prep. And I feel it's kind of coming back around to core again, and using as a handheld, but then what you're doing enables it to take core scanning to another level and be more systematic and automated.
Yeah. I think it's really interesting, isn't it, that we now have the ability to automate those measurements and attach them to multiple different sensors. And I think the latest incarnation of that in BoxScan is really showcasing it. That's our fastest growing product. We only launched it a couple of years ago now, and we've built so many of them. We built 10, 15 of these instruments, and buying so many Vantas, you can see them, all the boxes kicking around here.
And for all sorts of different commodities, right?
100%. So, Marcus, what's your feeling from that, from a core scanning perspective? You've been on the side of the portable XRF, and now you're on the side with us in the core scanning market.
Well, we saw the market heading that way. Hence, when I left my direct employment with Olympus, I came to see you guys and working with you now with the automation of it. I mean, the whole world's moving to digitisation of core and making data sets more consistent. Human beings are prone to error, James. Our customers on our box scan, many of them are using portable XRF, they're using hyperspectral, they're using MagSUS, and on our box scan system, we've added them to our laser and high resolution photography with a spray bar, being able to allow customers to do all of them automatically, providing more consistent data sets. So the customers we've been working with are, across the planet over the last couple of years. We've got iron ore, obviously copper being probably one of the hottest commodities around the world these days. We've got lithium, some good lithium leads here, particularly in the UK.
In the UK,
base metals and gold. Gold is still a hot commodity currently. So we're working across the value chain. And we're seeing the rise of battery metals within the market. Cobalt, that's being a very hot commodity. Nickel, anything to do with batteries is pretty hot these days. So basically, it's the automation of the equipment and consistent non-biased data set that allows the customers to put their core boxes into a box scan and press a button and get the data set.
What I find really interesting about this is you've got multiple different sensors all in one stratigraphy collected in a non-subjective, non-biased way that gives context to an individual assay measurement or an individual description. Where does it come from? What's the chemistry of not just this meter, but the last 10 meters or 20 meters or 50 meters? And how does that chemistry change, between 3 different holes? And that gives us some idea of the heterogeneity of a rock mass or the homogeneity of a rock mass, and makes us understand, what's our mineral deposit look like? Can we better define this at an earlier stage, or can we better understand what our mine is looking like? Or in the oil and gas market, what does our reservoir look like? What does spatial variation in that reservoir mean for production or for oil? Or in paleoclimate, how does organic content change? How does the trace metals tell us something about past climate change, and how does that change along a coastline? All of these things come back to is context, providing that context for an individual measurement or a description. And I think that's where core scanner data really drives its value. The other big aspect, I think, where non-subjectivity comes in, I don't know what you guys think about this, is the rise of AI and ML. How are you guys finding the rise of ML and AI and what you're seeing in the portable XRF market?
Oh, everyone wants to make sure they are using a sensor that is repeatable, so that they can make accurate algorithms and be reliant on the data that's being produced. So we're focused on reproducibility and stability. We're not quite there yet. Now there's always improvements to be had, but as you would know of what your story about the Vanta, we're pretty close.
It's the repeatability of a robotic system, automated system, why customers are now coming to us.
So it's sensor reproducibility and
measurement reproducibility. Yeah, absolutely. And that's where I think from our side, depth co-registration is so important, because we've got all these different data sets at exactly the same depth, automated, non-subjective, non-biased ways, and we provide these, these handheld instruments automated into a function with multiple different sensors like mineralogy, laser, like you were talking about, hyperspectral.
I think to take a step back from the AI/ML thing, like Xanadu in Mongolia, sure, we've got AI/ML on board the system, but to take a step back, what you're saying before, James, with the multi-sensor system and an unbiased data format, is you get 10 geologists looking at a rock, you'll get 11 different answers about what that rock type is. With a system such as box scan, it's going to be that rock. So the senior geologists who might not be on site, who are not there necessarily logging the core, they're going to be able to come back in and say, no, it is this rock type. And then they're going to notice that rock type for domaining for their resource. So step back, and then obviously you can then take it forward into the AI/ML world, and having a non-proprietary data set that customers can put anywhere. Our customers can choose their own adventure.
That's right.
That's what they do with their data.
And I think that's great. I think it's really great talking to you both, because it just shows the strength of the relationship that we've had over the years with not just the history that we're showcasing right on this table here, but in the future with AI and ML. It's great to share ideas and trying to help our customers, because that's our goal here, is how can we help them get their better models, improve their resource estimation in a whole range of different applications. And it's great to chat to you guys and continue to grow that relationship we've had over this number of years.
Yeah, for sure. Why are we doing what we do? Because this technology adds value to what our customers are doing, and we're stronger as partners. So it's been a pleasure working with Geotek for 15 years.
Yeah, it's great.
And it's nice to still be working with you, Todd.
Me too.
Thanks, mate.
Thanks very much, everybody. It's been great hanging out with these guys for the whole afternoon, and for sharing some of their views and some of the history of portable XRF and the history of core scanners and how we've used it over the time. Marcus, Todd, thanks very much for coming by and hanging out with us here. Thanks, guys. Thanks for watching.
Thanks.